All right, so 8.4, 446. We have 4 theorems to talk about. And all of them are pretty similar to each other. And I hate using that word in this chapter, but they're pretty close to each other. They're all about creating proportions. Okay, it's all creating proportions. And I'm going to say I'm going to set it up a certain way every single time. There are other ways of setting up these proportions, and I think you guys have realized that by now. But I'm going to continue to go based off of what they show in the theorem. And what they show in the theorem is always, if it forms a straight line, it becomes a fraction. Okay, so I'm going to keep saying that, and that's how I'm going to set it up. Are the parts that form a straight line, I'm going to write those as a fraction. There are other ways of doing it. Okay, just so that you know, find one that works for you, that's going to get you the right answer and go with it. That's completely okay. So the first one here, triangle proportionality theorem. It's taking a triangle and then drawing in a parallel line through the triangle. Now we saw something similar to this with our triangle mid-segment theorem. This is not necessarily a mid-segment. Okay? It would work as a mid-segment. Remember, mid-segment was at the midpoints of both sides connected. But this is not necessarily there. This line could be anywhere in this triangle. Okay? It does not have a set place. It could be anywhere. And so no matter where it's at, you can set up this proportion and it will be true. Okay? It breaks up those sides proportionally. So this would be like if we had, this is 4 and 8, and this is 5 and 10. Right? Wherever that vertical or that parallel line is drawn in, it will cut it up proportionally. So this would be 4 over 8 is equal to 5 over 10. And we know those both simplify down to the same thing. We know they're proportional. That's what it's telling us. Okay. As you can probably see, there are other ways of thinking of that proportion, right? We could think of it as 4 over 5 and 8 over 10. That would work as well. But the way that they're showing it, 4 over 8, 5 over 10. Okay. So that's what triangle proportionality theorem is telling us. If it's a parallel line, we can set up that proportion. Okay. And we're going to get real good at setting up that proportion because that's what they're going to have us do time and time again, setting up that proportion to solve. Either just for a length or we're solving for x or something like that. Okay. So now our second one is the converse of that. Okay, it's the converse, and now we don't know that it's parallel, but we know that it's proportional. And if they give us enough information to show that that these sides are proportional, then we can say this has to be parallel. Okay, so it's just going the other way on it. Right? If they are proportional, then we know the lines have to be parallel. Okay. So same idea, just backwards, it's the converse. Okay. This allows us to set up and solve for a side line. And we'll do 2 like this, and we'll move on to another one. Here's your first one. We're solving for RQ. Go ahead and set up, solve for RQ, or however you're going to do it. Solve for RQ. Check with somebody, see if they got the same thing, see what they did, how did they get it. All right, raise your hand, tell me, how did you set it up? How did you set it up here? Brody?
I did 4 over 6 equals x over 5.
what'd you get for an answer?
6.
6. There you go. Anybody set it up differently? Yep. And you got 6. Right? So, yeah, and it doesn't matter which way we set it up here, as long as you are staying consistent. So if you're gonna go X over 4 and you start with this side, you gotta start with this side on the other, right? 9 over 6. Either way here, right, cross multiplying, you're getting the same thing when you cross multiply. 6x is equal to 36, and we solve it out. That's why it's okay to set up those proportions. Okay. Next one, I'm gonna show you a little bit harder. That's why we're doing it. Looks like it should be pretty easy. No rounding, okay, need exact answers. Go ahead. No rounding. Exact answer, meaning right as a fraction.
Oh,
Talk to somebody about it. If you can't figure out how to get a fraction out of that, then talk to somebody, see if they can help you out.
Oh.
What you guys get for X?
No, I got.
I got 42.7.
All right, so we should have a proportion, something close to this, but when you cross multiply, we should end up here, 44x is equal to 1260, dividing by 44. And now our tendency is just to divide it, get a decimal, which is fine, right? But if you can't round and it's not an exact decimal, we gotta be able to change that over into a fraction. So you can either use the fraction to decimal button on your calculator, all right, which would help, or you're simplifying this fraction. And if you don't know how to simplify it in any other way, the top and the bottom are both even. And if they're both even, divide it by 2. All right, so this would be 630 over 22. They're even again, divide it by 2. That's gonna give me 315 over 11. Well, 11's prime, so unless 11 goes into 315, it doesn't. That's your answer right there. We can leave it just like that. Okay, we can leave it as 315 over 11. You don't have to change things into mixed numbers, guys. We can leave them improper. If you did switch it over, what was that end up being? 26, 28, and 7/11. There you go. 28 and 7/11. Should remember it. 28 and 7/11. There you go. All right, questions so far? Great. So we had our theorem and our converse are both true, which means that the inverse and the contrapositive are also true. I know it's been a while since we talked about those, right? But what that means is that if they're not proportional, then they're not parallel. And if they're not parallel, then they can't be proportional, right? It just means the opposite is true. Okay, so it has to be proportional if it's going to be parallel, vice versa, and if it's not, then it can't be proportional. It can't be proportional, it can't be parallel. All right, moving on. The next term that we have, very, very similar. I gotta stop using that word in the similarity chapter.
Very the same.
Very close to being the same. The only difference here is that it's not a triangle anymore. It's just 3 lines, okay? And you see in the name, 3 parallel lines there. So you have 3 parallel lines instead of 2 parallel lines and a point, but the idea is still there. You're setting up the proportion using those segments between the parallel lines. So you see here, UW, WY over VX, or is equal to VX over XC. Okay, so it's the same exact idea, setting up those proportions. Okay, so let's look at this one. We'll do one of these. A little more of a real world feel to it. But we are looking for HF. We're looking for that entire thing. Okay, so figure out, however you're going to figure it out. I want you to figure out what HF is, and then we'll talk about how another way that we can do it. Go ahead, talk it through with somebody. How are you going to find HF?
Oh, that is 121. It's a straight line. Yeah, because then we have 5 streets.
Wait, why would you say that?
What? Oh, let's try. I normally wear them in the back. I don't want them in the back.
All right, so there are multiple ways of doing this. Probably most of us solve for GH first. How many of you solve for GH first? At least a few of us, yeah. What can we set up to solve for GH, or how could we solve for GH? Here, Randy?
120 divided by 150.
Okay. And then what?
And then we get 0.8, and you multiply by 2.
Okay, so kind of finding like a scale factor, for lack of a better word, right? 120 over 150 is 0.8 times it here, get here. Sure, that works. Cool.
150 over 300 equals 120 over 300.
Yeah, set it up like the theorem, right? 150 over 300, 120 over X. You notice right away that that's double, so this is double, so this is 240. Once you get that, then we got to add it back onto the 120, right? So we can do that. Well, what if I didn't want to do that first? Right? How could I solve for X here, the whole entire FH? What proportion can I set up to solve for FH right away? Talk to somebody about it. How can we set up a proportion to solve for FH right away?
Yeah, put it on a graph. Over there, that's the proportion of X in my mind. So. We know it's bigger than 120. That's always actually. It has to do something with the angles. For some reason, or is it just another line?
Those angles are just telling you that the lines are parallel. Converse of corresponding. Aiden, what do you think? Yeah, so what we can do is we can match up that X with the entire thing over here. Okay, yes, we know these are proportional, right? We also talked about matching up side to side. But you can match up this whole thing with this whole thing. So if I was doing it, I would probably do like 120 or X over 120. So the whole thing over the part is equal to the whole thing over the part. Obviously, other ways you can set it up. But you can use that entire thing. You can combine more than one section together. That's still proportional. You're gonna have to do that in the homework for a couple questions, okay? Where you have to do the whole entire thing and match that up. Okay, it is gonna give us 360 right away. That allows us to not have that extra step that we might forget to do of adding it onto the 120. All right. And then our last theorem here. Slightly different. Now we don't see parallel lines anymore. Yeah, we got an angle bisector, right? So we don't have parallel lines, but we got that angle bisector. We're still setting up a proportion. And the thing that I said at the beginning of the lesson still applies here. If it forms a straight line, make it a fraction. You got 4 different segments that we're talking about here. These two form a straight line. So these two are creating a fraction, AD over DB. You see it here, AD over DB, with those two that form the straight line. And then you just got to stay consistent with it. If you're starting up here, AD over DB, then start here, CA over CB. Okay, so it's again, just making sure that we know how to set up that proportion with the values that are provided. Okay. So one that we need to look at, I didn't look at this in the other classes and they had a bunch of questions on the homework because of it. Let's solve this one. Okay, we're going to set up that proportion the way that the book has it. It's talking about these two being a fraction, QR and RS. I know RS is X. What can I put in there for QR? It doesn't tell me anything about QR right now. It tells me the whole thing and it tells me RX. Well, 15 minus X. Because if this whole thing's 15 and this is X, this part has to be whatever X is, 15 minus that. So we're going to set up that proportion with 15 minus X over X is equal to 7 over 13. Hey, now it looks just like a warm up, right? Go ahead, cross multiply and solve it. Once you get it, check with somebody because they got the same thing. All right, so we see it up here. All Now you get 9 3/4. 9.75 is gonna be fine because it's an exact answer. We didn't round it. So the decimal actually is okay there. Because we didn't have to round it at all. Okay, if we have to round to get a decimal, then it has to be a fraction. As long as it's exact, then we're good. So 9 3/4 there. 9 3/4, however you want to think about it. There you go. All right, any questions on our stuff today? All right. Go ahead.